Hello, my name is Adam Rutherford, and I'm here to present an attrition analysis for DDSAnalytics. In this presentation, we're going to be discussing how the data provided to me was analyzed. We did some exploratory data analysis. We derived additional variables from the ones presented to us in the data. We then have the selection of attrition models and what criteria we use to judge them. The two models, K and N, naive Bayes, a linear regression model which was used to predict monthly income, also a statistical analysis, and then our conclusion. In the exploratory data analysis, each categorical variable was plotted individually, and it was examined for outliers, attrition versus whatever the corresponding thing. In this case, we have marital status and stock option level. So for marital status, we can see we have divorced, married, and single, with the single having a greater than 25% attrition rate. Stock option level presents something interesting because there the 0 level and the 3 level had the most attrition. Derived variables were created from the variables presented to us in the data. And looking at the previous two, a single variable is single was created from marital status. And then stock option 3.0, which means stock option level 3 or 0 variable was created for that. You can see the code that was used to do that on the other side of the page. For our attrition model, we were looking for two things, sensitivity and specificity. Both of them needed to be greater than 60%. The root mean square error for our predicted monthly income needed to be less than $30,000 or $3,000. The thing to remember is because only 1 in 6 employees in any given year leaves or trits, the specificity metric is very difficult to meet. We're trying to find something that's very small in something that's very small. So it became the overriding concern in model selection. For K and M, we created a model using a loop where we simply measured every variable against every other variable. We did this several times, first a 2 variable, then a 3 variable, and then took those things and tried to do it. The best we could do, though, was only a 35% specificity. The 4 parameters that ended up giving the best model was overtime, single, monthly income, and job level 1. Naive Bayes, we had much better luck. We initially started with all the variables, and then threw out the ones that did not improve model performance, or kept the model performance the same. We had to create some additional derived variables. The finished model was run in a loop and the results were evaluated. We looked for multiple Laplace values. A Laplace value is simply a way of shifting a model value. For instance, in our stock option level 0, a 0 does strange things to the naive Bayes, so a 1 would actually work. So you would simply shift all the values one level. Our model, our looped model, the typical results that we obtained, we had a Laplace of 3, sensitivity almost 80%, and a specificity of 62%. For a single run of the model, we found that the Laplace, again, if they equal 3, we get our best results. Sensitivity 78-79%, and specificity about 67%. For our linear regression models, we were looking for a root mean square error of $3,000 or less a month income. We achieved 1,387. The regression model uses 3 factors: years at company, total working years, and job level. And all 3 factors have an alpha of less than 0.01%, or 0.01, meaning greater than 99% accurate. Statistical analysis, the 3 parameters and the intercept value all had very, very low p-values. The highest of anything was the years at company, and it was 0.00158. So very, very low p-values. Consequently, we had a very, very good alpha for this, very low alpha. Again, the linear regression, we have a root mean square error of 1,387. Naive Bayes has an average sensitivity, the final one, of 76-80%. Specificity was 60-63%. And again, for K&M, we were able to get to 35% specificity. So our conclusions. The naive Bayes provided severe performance compared to the K&N model. It was just better all around. The two models shared these three data points: overtime, monthly income, and marital status. So these are some of the most significant columns that we have. We were able to achieve our sensitivity and specificity model desired criteria limits using naive Bayes, and the final linear regression model had an acceptable RMSE. Thank you for your time, and I hope you found this useful.